had regular migrations.
No, it's still going, I think.
Now, if you guys do like to define a single schema, have it be automatically migrated to your device. Current Rails doesn't do that, but when data map are supported, you'll be able to do that. So when Rails 3 is supported, you'll be able to just define Rails schema once, and then it'll handle all the migration magic for you.
Good afternoon. Thank you very much for coming. Today we are showing you the world's first Ruby-powered autonomous blimp. Project Flying Robot. We never actually flew it in this large of a space, so there's a lot more air currents than we expected. So, anyway, we're going to do a manual retrieval here. All right. So today we are not going to talk about web technology at all. Nothing to do with the web. We have a little test flight of Rogue One. We're going to do a short history of open source autonomous flying vehicles. We're going to talk a little bit about our architecture, show you some of the hardware, and then after that, we're going to make our own flying robot. This presentation is completely different. We have no slides. We don't believe in PowerPoint or Keynote. We're going for it. We're not only going to do live coding, we're going to do live coding of a flying vehicle. And you can try this at home. It's a lot safer. So this is a real blimp. It's the USS Shenandoah. It was the world's largest light and air vehicle. It was built by the United States in the 1920s. And at the time, it actually held the entire world's helium reserves. So naturally, when it crashed and was destroyed later in the 20s, it was a bit of a problem, and it actually set flying airships back probably almost 90 years, it would appear. So, physical computing, who knows what that word means? Physical computing. Yeah, I know you do, Jim. Well, physical computing is computers that do things here in that other place. You know, the real world. And there are amazing things you can do, moving things and flashing things and reading instruments and finding out what's going on out here, outside the matrix. So a couple of years ago, a really amazing project started called the Arduino project. How many people know what Arduino means? Okay, that's great. For those of you who don't, it's actually open source hardware, not just open source software. It takes and it uses something called the ATmega microcontroller. A microcontroller is kind of like a microprocessor, like is inside your notebook computer, but it has a different purpose. Its job is to communicate with devices in the outside world. So programming in Arduino is done using C++. Kind of scary. A wonderful guy named Greg Bornstein said, that's interesting, but I like Ruby a lot better. So he created a project that's known as RAD, which is short for the Ruby Arduino development. And what it does is it lets you take and use a Ruby domain-specific language, meaning a nice little simple language to program the Arduino, and then takes that and it converts it into the C++ code that's being run natively. So simultaneous to this, another pair of guys, Chris Anderson, the Wired magazine editor, and his partner in crime, Jordi Munoz, have been working on a variety of unmanned autonomous vehicles based on Arduino. And we thought, wow, what if we could get this cool open source hardware community and all the Ruby programmers together, then we'd really have something impressive. So that was the beginning of Project Flying Robot about 6 weeks ago. So let's take a look at the big picture. This is the flying robot architecture. And we see here that we have some Arduino-based vehicle with an XB modem. Anyone here know about XB? XB is a wireless radio frequency modem that lets you communicate over long distances using very low power. It uses the 805.14.5 protocol, which most people have never heard of, but it's a point-to-multipoint protocol. And it's designed for inexpensive, low-powered devices. And so one XP talks to another, and then we have some kind of ground control software. In this case, we were showing an application written in shoes. Anyone here know about shoes? All right, well, shoes is a way for you to create graphical user interface applications using only Ruby code and to distribute them on multi-platforms. So we thought, wow, let's just use Ruby everywhere for everything. What other language is there? I mean, besides Erlang, but that's something else. I broke my promise, I said something about the web. So this is basically the way, the other part of the protocol. One part is a digital protocol for controlling unmanned autonomous vehicles from the ground, and the other is a plugin architecture. What Ruby Arduino development lets you do is create Ruby-based plugins for all the different hardware devices you might want to communicate with. That way you don't have to know a lot about the different hardware to integrate it with the solution you're trying to build. In our case, we went and we created a bunch of new Ruby Arduino development plugins for reading our lithium polymer battery, our digital compass, IR sensors, a GPS, and all sorts of other things. And then we found out that this very small blimp envelope won't hold much weight. So most of the software that we were going to be showing we had to discard for today's demo because we just couldn't carry enough. So anyone who wants to help buy us a bigger envelope, talk to us later. So now we're going to take a little look inside. We're going to look at the hardware. Yeah, hardware is cool, right? So we're going to bring that camera here. I put on my chat, people are going to start chatting with me saying, hey, how's it on RubyConf? Oh, we'll do it anyway. Anyway, we'll talk to your computer.
I'll just start talking to you guys a little bit. As you can tell by the aeroplane get up, I sort of embrace the spirit of adventure associated with building an airship. Too bad Sky Captain is a terrible movie. Anyway, I don't know how well you're going to be able to see this and change this camera up, but I was going to take you guys a little walk through the guts of our UAV here. The most prominent feature you can notice here is the XP modem. Anyway, I'll just hold this up there for you guys. This is the XP modem. We decided to go with the Pro due to its longer range, potentially up to a mile, which, considering its maneuverability characteristics, you guys noticed it can't really handle much of a gust, even with the air conditioning. So I think it's probably going to limit it to indoor usage for right this minute. Tucked inside here is the servo that we use for the thrust vectoring of the motors, so you can have a little bit of elevation up and down controls. We actually use a clone of the Arduino, which I have another one here called the Door Board, which for about $10 is all it takes to make the brain of your system. And it's a pretty small package, although there are actually smaller ones out there, which we're heavily part of this weight, and we're probably going to go after the surface mount versions of these same parts to reduce weight after weight and be able to hopefully cram a few more sensors into get a. One little piece that we were able to add that we may try to demo later is we were able to also get a small digital compass installed, which we can use to figure out your heading and also to navigate to particular headings. And that was the only thing we could pretty much fit in weight-wise. You may have noticed the video signal that's on the screen up there. We just used a small, cheap security camera. Oh, wow, that helps. Did anyone hear me before? Or? No? Yeah. So, we're okay? Anyway, we used a small cheap security camera that operates at 2.4 gigahertz for our video feed. That was basically the only option that we had right now because it was sort of quick and dirty. We only had this idea not too long ago. In the future, we'd probably get a camera that we could rig through the XP to deliver the signal so we don't have two competing signals. That was a cause for some interference that we only kind of barely got around. Yeah, well, that's a breakdown of the inside. And also, we can use the XP modem, just another little fun tidbit. Through a lot of trial and error, we discovered we can program the board wirelessly using the XP modem. So if we want to upload new code while it's in the air, we don't have to pull it out, connect it to USB, et cetera, et cetera. Also, we went with a lithium polymer battery for our power source. They're great due to their energy density and they're pretty light. One note about them though, you really need some sort of battery monitoring software, which is part of our the Flying Robot gem. And you need that because if they go below a certain voltage, it will die and not able to be charged again, and there goes your $27 battery. We learned that the hard way on a couple of dead ones. There are ways to bring them back to life, but the law prevents me from describing them to you as they could result in fire and explosion. So.
But you can find that online. Yeah? It's amazing how much stuff we've either melted or blown up while learning about flying blimps. So on that note, we're going to, how are we doing on time? Well, we're going to actually take a brief moment and create a new flying robot. Hopefully. Let's see what happens. So the first thing we're going to do is start a new Ruby Arduino development project. We'll call it LA Ruby. And that is going to create the new skeleton for a Ruby Arduino sketch. And then we'll turn that into a flying robot project. Not a lying robot, that's something else. And what that is going to do is take and it's going to overwrite our main sketch, replacing it with the flying robot protocol, and it's going to install all of the plugins for the different hardware that we're currently supporting.
We're going to keep the blimp tethered while we upload experimental software, just for obvious.
This time you might want to duck, when we say, not right this minute. All right, so here's the basic project, and it's called LA Ruby, and I apologize for the screen resolution. Let's see if we can look at what it is. You guys see okay? All right, so the way that it works is it defines a standard list of commands that any unmanned autonomous flying vehicle would need to respond to. For example, a hail command. When it is sent hail, it responds Roger. Things like elevators, rudder, the throttle, autopilot, these are all the standard interface, which has already been defined. And so you just need to implement those in order to make your own flying vehicle. So let's start by changing our baud rate to 19.2. And the reason for that is the XP modems can only communicate at a fixed baud rate. It can go faster, but the old, cheap Arduino clone that we're using for this only supports up to 19.2. And so we're going to define a couple of the hardware things that we need. One of them is the software serial interface. And we're about to upload this code wirelessly, if all goes well.
Just like the rovers on Mars.
So this first thing is saying we're going to use a serial interface to communicate with the separate motor controller that's controlling our motors. And we're going to assign to it pin 3 and 10 from our Arduino's input outputs. And we're going to call it main for our main motors. Let's just call it main engines. And then we also need a reset for those, which is going to be an output pin. Come back. It's not supposed to do that yet. I wish I had planned to do that. That would have been so fun. So output pin 4 is going to be the main reset.
Yeah, once you pick up your own Arduino, you'll be able to get it pretty quickly with the ins and outs, so you can set the things. It's pretty open as far as what can do where.
Okay, so we've defined our pins that are going to control our little Palolo motor controller, and now let's make the throttle do something. And we're going to say, if our current throttle direction is forward, then turn the motors on and go forward. Kick is the name of the pullovers protocol, so that's why we have that. And we're going to say that motor, which one's on there? Motor 2 is the left motor, and we're going to turn it forward at a speed of, let's say, 20.
We went through several motor controllers, both through burnouts, and because there wasn't enough power that could process through the smaller motor controller we got initially, which led to problem heating and eventually drive several fairly expensive motor controllers. We upgraded to a larger size that was able to handle a lot more throughput, which is why well, it's speedy enough, the torque of the spin. Anyway, with the upgraded motor controller, we're able to get a lot more power through the motors. In fact, so much power that if I go full throttle, the spin of the motors itself will cause the thing to careen off to the other direction, sort of like a helicopter kind of rotating. This is something we didn't really expect to happen in something this size. We didn't think we'd ever get it done fast enough for that to be an issue. So a fix we have planned for that is process or reverse pitch so we counter rotate them so that they just go straightforward and hopefully pretty.
Okay, so I'm going to interrupt here, sorry. So here we're saying if the current throttle direction is forward, we're going to turn on both motors going forward at a strength of 20. Otherwise, we're going to turn them off to 0. That way we have a way to stop it. When we were practicing this demo, we realized, oops, we forgot to turn them off, and so that was kind of embarrassing. The last thing we need to do is we need to initialize the motor controller. The Pololu requires some initialization, and that way, in case something goes wrong, it will turn itself off. So we say quick reset, and we tell it to use the mains. What do they call it again?
Don't feel good where blogs will post it again on the more information.
Okay, so now at this point, it should be able to be compiled and uploaded. Replace the battery? Replace the battery so we don't destroy them. So let's use a rake command that comes with rad to hopefully upload the code. Let's see what happens. It compiles it. Oop, had an error. Live coding. That's quick init. And we'll try again. Okay, so it's going to try and connect wirelessly. Hopefully this will work with all the wireless interference in here. No, we'll try again. And this is using AVRGrid, which is a standard utility that comes with, we'll hold them closer. Close, but not touching.
Not quite as large yet.
There it goes. And it reads it back to verify that it's written the data to the flash RAM that's on the Arduino. Okay, we've just reprogrammed, using that little sketch we made, our own mini flying robot. So let's test it. I'm going to use the screen program to send it the serial commands directly. So we'll start by hailing it. It hails, Roger. And we'll check its status. Operational. Hang on to the tether. I'm going to tell it to throttle forward, and that should turn on the motors. Applause. Now I'm going to set them to reverse, and that should turn them off. They're off. Okay. So as you see, it's just using a very simple serial communication protocol. And the thing that really amazed us was you go out and these guys spend like $2,000 on this amazing flying airplane and they're controlling it with this little, $20 potentiometer, dial. And I mean, if you go out to the United States government, do they use a Wiimote to fly a Predator? No, they use a joystick. Right? So that's actually one of our next projects is we're going to use an Arduino connected to a joystick to create a complete standalone ground control that supports this protocol so that you don't need a flaky laptop computer. So let's hopefully go back and reprogram it with the original code now. So we're going to try to reload the code from before, which is a lot more complex, and hopefully it's going to work. Here it goes. Keep your fingers crossed. We found that with a lot of Wi-Fi interference and the exact same frequency spectrum, it sometimes isn't happy, but this time it made it. So we've just re-uploaded the original code that we were showing when it was flying around before. And now it's verifying it. So you can just use all the standard tools, and we're just providing ways that you can say, take some different pieces that you have around and combine them together. So let's talk about the future for a minute. The future. If you want more information, go to flyingrobo.com. You can also check out my blog at deadprogrammersociety.com and Damon's blog at myfirstairship.blogspot.com. So right now, the Flying Robot Gem is available as of yesterday. You can actually go on GitHub, download it, you can get rad, you can try this all out yourself if you have one of these. A more traditional Arduino board that you can get from places like SparkFun. And this is when people say Arduino, this is what they're thinking of, not necessarily that, but what we're really trying to show is that using these standard bits of open source hardware and software, you can go off and say, create your own flying blimp. In fact, there's already a standard reference platform for Arduino-powered autopilots. One of them is called Blimpduino. Blimpduino is the flying blimp that Chris Anderson showed at the TED conference. So if you think we had problems, you should have, they didn't even get theirs working. They stood there and held it the whole time. I really feel for those guys. Luckily, because they learned all those things, ours pretty much work today, so.
Also, just so you guys know, while we spent a fair amount in development, the actual parts in this thing, if you follow our parts list, is a little less than $200. So for less than $200, you can have your own vehicle that's complete with the camera, the whole rig, which is a really fun toy, great to play around with. If you want to cruise around your living room, filming your family and friends, it's not that big a deal to get involved in it. And the stuff you learn about hardware, the stuff I learned just about soldering and the batteries and correct ways to wire things. I never built a robot before, and so I figured the best way to go is just jump in, way over your head and start building and see what you come up with. And there was a lot of failed attempts along the way, a lot of boards that we ended up having to scrap because we just didn't, quite know what we were doing. And as we figured it out and worked our way through, we, came up with something that's, a lot of fun. And so yeah, feel free to go out there and jump into.
You can make your own paparazzi bot just like this one with a $25 camera. So should we fly one more time? What do you guys think? Oh yeah. All right, let's do this. The application written here in Shoes is also available on GitHub. It's called Mercury. And that's our digital compass, which is an actual Honeywell digital compass. In fact, why don't we show that? We wrote a very simple little autopilot, which isn't very smart, but it does more or less know how to find north and stay there. So let's try it. We'll turn on our autopilot. See how it's trying to find north. so it looks like it's trying to find its way out. The blinking lights inside of the XP motor.
Well, there's several. There's an LED readout on the motor controller, on the Arduino, or the board itself, and the XP.
It wouldn't be an Arduino demo without a blinking light. That's kind of required. All right, so we'll turn off autopilot and stand by. And we thank you very much. Flying robots. Yeah, pointed at them. They're softer.
Yeah, it's expensive. What if you crash my robot in your car?
We might mention that this is only 2 motors and 1 servo. So we're able to get a full 3-axis of motion.
I've seen a lot of noise flying with my roommate, but not stuff off the shelf.
How many laptops have you knocked off the table?
Trying to distract myself.
We're not going home, we're just going to fly all day. We'll trade it for any one of these cars.